Okay, so here we are back in a discussion about scientific inquiry. Scientific inquiry, remember, refers to the diverse way in which scientists study the natural world and propose explanations based on experiences that they gather. So this is going to be the process that we use to do science. And the scientific inquiry process, as I know you know, all starts with a question. This question can be about really anything. Our questions come from everything around us, everything in our natural world, and they're similar to our wonder wall. The key is that they are testable. We will typically test our question with a hypothesis. So we take our testable question, testable meaning it can't be answered with a yes or no, testable meaning that somehow it's going to create data for us. The other thing we talked a lot about today in class was this concept of what effect. What effect does the independent variable have on the dependent variable? By asking what effect when we pose our question, we are able to immediately identify the variables and then able to develop a hypothesis. So as we go forward, whether we are doing a lab or whether we're just practicing writing questions, try using what effect does the independent variable have on the dependent variable. That will also help us when we're developing a hypothesis, which is the second step in the scientific inquiry process. It is so important that we remember that the hypothesis is a possible answer to the question we asked. So if I was asking, what effect does a microwave beep have on a PowerPoint, then I would be able to measure the effect, measure the distraction you just had, and also measure the distraction that I'm having as I'm trying to talk. Did that make sense? Probably not, but we will move on. The hypothesis has to answer the question, and it has to be testable. The other thing that it must be is in an if-then format. Always, if-then format. Don't forget an if-then format. For example, if I add baking soda to vinegar, then it will bubble because of the chemical reaction occurring between the two compounds. See the if, see the then, and then notice that sometimes we include a because. This happens more when we are communicating results and restating the hypothesis, but the if and the then are always essential. And again, it's if I add baking soda to vinegar. So I'm changing the baking soda. I'm adding baking soda. The amount of bubble is the thing I'm measuring because I added baking soda, which leads us into, we'll skip this one for now, but feel free to pause at this moment and reread over it. But it allows us to isolate our variables. In order to follow sound scientific principles and for results to be determined valid, you have to isolate the variables. A variable is simply any change in your experiment, whether you meant for it to happen or whether it happened on its own. A variable simply means any change. We call out three types of variables. Number one is the manipulated variable. Sometimes we also call this the independent variable, and you may remember, I am an independent person and I can change whatever I want to. And it's okay, because when I do, people depend on me. So I'm changing the independent variable to test the hypothesis, and the things I change are going to have an impact. So again, this whole baking soda and vinegar. I changed the baking soda, and because I did, the baking soda and the vinegar caused bubbles. So the bubbles were the response to the amount of baking soda I put in there. Responding variables we also call the dependent variables. They're the ones that change because of the change you make, and they also give you an idea of what is happening in the experiment. So again, baking soda and vinegar. If I add more baking soda, then I will have more bubbles. Something along those lines. Something else really important about the dependent variable is it has to be measurable. You have to be able to quantifiably see the effect. And then there are constants. Remember, a constant is anything that has to stay the same. We want to keep constants from changing. So I know that variable means change, and I know that we're trying to keep them constant. You can think of it constant from change, not changing. These are how we know that our experiment is only testing exactly what we want to test. So for example, if 4 types of grass are planted, then bluegrass will grow the fastest because it germinates the fastest. What is my independent variable? What is my dependent variable? And what kind of things will I need to keep constant? If you're looking for a challenge, you could also write the scientific question that would pair with this hypothesis. If 4 types of grass are planted, then bluegrass will grow the fastest because it germinates the fastest. My independent or manipulated variable is my type of grass. The responding variable will be the growth of grass. And then constants, I would need to keep the amount of, there's the beeper again, I would need to keep the amount of water constant, the amount of sunlight, the amount of dirt, etc. Maybe a scientific question could be, what effect does type of grass have on speed of growth? Notice again that what effect? Independent, type of grass, dependent, growth of grass. After you've went ahead and done your experiment, you've conducted the experiment, you're then able to collect and interpret your data. This is always done with a data table, which gives you a clear picture of your information. Notice along the left side we have our trials. Along the top where a title would be, you have your dependent variable. Along that top box where you're actually putting information, your independent variable is going to be listed across the top. We also talked about in class how this, and I don't know if you can see my mouse or not, I'm circling around the cricket, is just labeling that far left column. So it's still our trials, but instead of having 1 cricket, 2 crickets, 3 crickets, it just says cricket. So we could have just as easily named them Cricket Bob, Cricket Jan, Cricket Mr. Richard, Cricket Mellicat, Cricket Spaghetti on the Stove. We could name the crickets anything we want. For this, we just named them numbers. Then we have to communicate our results. The important part of communicating the results is just stating what happened. You want to answer the question whether or not you were right or wrong, but we don't phrase it that way. We say, my hypothesis was supported because. My hypothesis was not supported because. Today in class, we also talked about this concept of error. If there's an error in your experiment, it's not you. So when you're communicating results, don't say, I messed up. Say, an error in the experiment was we did not control, or a constant could not be the lighting or the air. Your constants are things that might be controlled in your experiment. Your errors are the ones you couldn't. The errors don't reflect you. You are fabulous. Errors are just errors. Same thing. And then we also talked today about theories and laws. Remember that unlike a theory, a law describes an observed pattern in nature, but it doesn't try to explain it. It just says, this is what happened. Force is equal to mass times acceleration. I was this massive, I was going this fast, I hit the brick wall with this much force. And our theories try to explain what's going on. Why does a black hole behave the way it is? What is it doing? So forth and so on. And this brings us back to the beginning. I hope that you have a wonderful evening, and if you have any questions about this, feel free to see me tomorrow morning before school, or just hit restart and watch it all over again. Have a great night. Good luck.